Hello upper primary students, I'm Victoria Carthew and I'll be sitting in on your English, math and science lessons today. Coming up in English, we're going to talk about creating different characters. In maths, we'll cover acute and obtuse angles, and we're going to look at innovations from space when we move into science. So, get yourself settled and let's begin. When we read or listen to a narrative, we can become invested in the characters, who they are, their personalities and appearances, their actions, and what they say and think. Today in English, let's explore how authors use different language features to create character traits.
Hi everyone, I'm Rebecca. I don't know about you, but there are some characters in books, movies, or television shows with whom I become emotionally invested, and other characters who I never really connect with. Today, we are going to look at how authors use different language features to create character traits in narratives. But first, do you remember what a narrative is? A narrative is a story of events or experiences, real or imagined. Stories include characters. Characters are the representation of people, or sometimes animals or other things that has a role, in a story, conveyed through a selection of physical attributes and character traits. But what are character traits? Character traits are qualities that describe parts of a character's personality or nature, or underlying values and beliefs. For example, whether they are honest, loyal, devoted, careless, selfish, or enthusiastic. The creation and development of a character by an author over the course of a novel can be direct, so telling the reader what a character is like, and indirect, showing the reader through the use of techniques and strategies, such as language features. Today, we are going to read a narrative poem to investigate how authors develop character traits indirectly. The poem we are going to read is The Man from Ironbark. This poem was originally published in 1892, which is over 120 years ago. As such, it contains some words that you might not have heard before. To help us understand the poem, let's have a look at these words. One word you might never have heard of before is toff. In the poem, the man from Ironbark says, "I'll go and do the Sydney toff up home in Ironbark." A toff is an old-fashioned slang for a very fancy or posh person. In this sentence, our character is saying he will go back to Ironbark as a fancy or posh person from Sydney. He wants to return home looking highly sophisticated. A word you might have heard of before but never used is loiter. In the poem, the man from Ironbark loitered here, he loitered there. If someone loiters, they are standing around or waiting without purpose. Let's have a look at our poem. We are going to read the orientation to this poem. The purpose of an orientation is to capture the audience's interest, introduce the time, place, and characters, and set the scene. This means we should get a good idea about the character traits of some of our main characters. Would you like to read along with me? Let's begin by reading the first few stanzas of the poem. The Man from Ironbark. It was the man from Ironbark who struck the Sydney town. He wandered over street and park, he wandered up and down. He loitered here, he loitered there, till he was like to drop. Until at last in sheer despair he sought a barber's shop. "'Ere, shave my beard and whiskers off, I'll be a man of mark. I'll go and do the Sydney toff up home in Ironbark." After reading the first few stanzas, how has the author used language features to develop the main character, the man from Ironbark? Let's take a closer look. While we do not know the character's name, we do know about their gender and their age. Skim and scan the text to find the answers. That's right. We know our character, the man from Ironbark, is a man because the author has used the pronoun he. For example, he loitered here, he loitered there, till he was like to drop. Age might have been a bit trickier, as we're not directly told how old our character is. However, we do have some clues in the poem that help us think about how old he might be. "Ere, shave my beard and whiskers off, I'll be a man of mark." This lets us know he is old enough to have grown a long beard that requires shaving. This means he's probably over 30. The orientation provides us with some information about the type of person the man from Ironbark is. It is in the orientation where we get a sense of his character and how comfortable he is with himself and his place in Sydney. Let's reread the beginning of the orientation, thinking about his personality. "It was the man from Ironbark who struck the Sydney town. He wandered over street and park, he wandered up and down. He loitered here, he loitered there, till he was like to drop." What does this tell us about the personality of the man from Ironbark? That's right. It helps us understand that the man from Ironbark is new to Sydney and that he probably does not fit in. We can see that he might not be comfortable and perhaps he feels like he does not belong. There is one other line in the poem that you might have looked at to help understand our character from the man from Ironbark. "Until at last in sheer despair he sought a barber's shop. 'Ere, shave my beard and whiskers off, I'll be a man of mark.'" In these lines, language has been used that gives us an insight into our character's personality. The words "in sheer despair" suggest that our character is desperate to have his beard trimmed. This makes me think that he does not like his beard and that he might think it makes him stand out and cause him not to fit in. I think he's very self-conscious. The words "I'll be a man of mark" tells us that he wants to be important. He wants to be one of the fancy and grand people. Having his beard trimmed will make him feel and look more sophisticated. This further makes me think that he is self-conscious and unsure of himself. Through the careful selection of language, the author has been able to give us an idea of what our character, the man from Ironbark, is like. The author, Banjo Patterson, introduces us to another character in the orientation. As we read, think about the character traits you can identify for the barber. The barber man was small and flash, as barbers mostly are. He wore a strike-your-fancy sash. He smoked a huge cigar. He was a humorist of note and keen at repartee. He laid the odds and kept a tote, whatever that may be. And when he saw our friend arrive, he whispered, "Here's a lark. Just watch me catch him all alive, this man from Ironbark." What personality traits did you identify for this character? You may have identified some of his physical features. He was small and neat and probably wore fashionable clothes that were neat and tidy. You may have thought he is cheeky, cunning, or a prankster. I think the fact that the barber thinks it would be a lark or a joke to play a trick on the man from Ironbark tells us that he thinks the man from Ironbark is an easy target for jokes, and he might not like him very much. I think the language used by the author, Banjo Patterson, has really helped me understand the characters in the orientation. When writing narratives, authors use a variety of language features to describe character traits, both directly and indirectly. Why don't you read the rest of The Man from Ironbark to find what happens between the man from Ironbark and the barber, and see if any other characters are introduced. Can you describe their character traits? You might like to describe the character traits of someone you know. Be sure to use a range of language features to really capture what they are like. See you next time. Bye.
Thank you, Rebecca. Now, stay with us for more Learning at Home TV. After the break, you will need a pencil and some paper for a mathematics activity. Okay, everybody, I hope you have a pencil and a piece of paper handy for this mathematics lesson. Have you ever been in the car waiting for a train to pass and noticed the railway crossing sign? Well, Will has, and he decided that it would make a great example as a teaching opportunity. So I think that we'll just let him explain what he saw.
Welcome, everyone. We can look for mathematics everywhere we go and in everything we do. Driving to the studio this morning, I was stopped at the railway crossing waiting for a train to pass. The bell was clanging, the red lights were flashing, and this sign stood in its place. It caught my eye as I had been thinking about angle relationships and especially vertically opposite angles. And there was a real-life example in front of me. Let's backtrack a bit and have your pencil ready. I'd like you to draw a letter X on your page. Mathematically speaking, we've drawn two straight lines that have intersected each other. Look carefully and notice the two intersecting lines create two pairs of vertically opposite angles. We can label the two pairs of opposite pairs of angles with a symbol. And for bonus points, can you recall the name we give to the pair of smaller angles and the name for the bigger pair of angles? The two smaller angles on the left and the right side of the diagram are acute, that is less than 90 degrees, and the two larger angles, top and bottom, are obtuse, meaning they are larger than 90 degrees but less than 180 degrees. You may have learned about these types of angles before. In case you're a bit rusty, here's a list of the angle types and what sizes they are. Acute angles are less than 90 degrees. Right angles are exactly 90 degrees. Obtuse angles are greater than 90 degrees but less than 180 degrees. And a straight angle is exactly 180 degrees. A reflex angle is between 180 degrees and 360 degrees. And a revolution is equal to exactly 360 degrees. Now, here's a brain teaser for you. Have a piece of paper and a pencil ready. Can four acute angles be created with two intersecting lines? I'll give you a few seconds to see if you can create a diagram showing that. It's impossible, isn't it? With just two intersecting lines, only a maximum of two acute angles are created, not four. The explanation for this comes from the number of degrees in a revolution. As one revolution is 360 degrees, there's no possible way that four angles, less than 90 degrees each, could add to 360 degrees. So let's think about what types of angles can be created from two intersecting lines. Perhaps there's some room on your piece of paper to sketch some different looking lines and see what you discover. If we draw a letter X, we can have two acute angles and two obtuse angles. And if we draw a compass rose showing north, south, east and west, we can create four right angles. Are any of the angles created with two intersecting lines the same? Well, our compass rose had four equal right angles, and our letter X had two equal acute angles and two equal obtuse angles. When two lines intersect, four angles are formed at the point of intersection. In this diagram, angles YOB and AOX are called vertically opposite angles. If you have a protractor at home, you might like checked the vertically opposite angles in your letter X and in the simple compass you've drawn. If you measure carefully, you will show that the vertically opposite angles are equal. This is a generalisation we can use in geometry. This generalisation can be useful. If one angle is unknown, it can be calculated by looking at the opposite angle without having to measure with a protractor. How good is that? Let's see if we can calculate some unknown angles. Have a look at this. In this situation, angle AXC is equal to 78 degrees. And using our rule that vertically opposite angles are equal would mean that angle DXB is also 78 degrees. How did you go? Shall we try another? Let's have a look at angle PXM, which is 121 degrees. So that would mean that angle NXO must also be 121 degrees. I can see you're getting really good at these. Shall we try one a little bit harder? Can you find angle QXT? How did you go? Could you see that angle QXT was vertically opposite to angle SXR. We were told in the question that angle SXR was 92 degrees. So that means angle QXT also has to be 92 degrees. Okay, one more to challenge ourselves. Could we calculate angle TXR? We know the angles either side of it are 92 degrees each. So how could we approach this problem? We could use our knowledge of supplementary angles on a straight line. We could use our knowledge that supplementary angles on a straight line add to 180 degrees. So we need to subtract 92 degrees from 180 degrees to reach our answer of 88 degrees. Wow, you've done some great work this lesson. Now you're thinking about vertically opposite angles. Can you think of some other real-life examples? How about the angles formed by an open pair of scissors? Here's an illustration. Can you see where the vertically opposite angles occur? That's correct. The angle formed between the blades is vertically opposite. The angles formed between the handles. Have you ever constructed a kite? Kites are often made with two lengths of bamboo tied together, and then some sort of covering is attached to the frame made of the bamboo. Where the two lengths of bamboo cross are vertically opposite angles. Here's a simple illustration of a kite. Can you recognise where the pairs of vertical opposite angles are? That's right. They are at the point of intersection, and in fact we have 4 right angles formed here, which is also 2 pairs of vertically opposite equal angles. These vertically opposite angles being equal is really going to help us with some of our geometry in the future, isn't it? Okay, let's recap what we've learned so far. We know that intersecting lines create 2 pairs of vertically opposite angles, and that vertically opposite angles are formed when 2 straight lines intersect and are always equal. Well, we've done a lot in a short time. Later on, you might like to draw some intersecting lines and measure one angle. Then calculate the other missing angles without using a protractor, or perhaps you could experiment with different angles in a kite. Keep your eyes open and see how many vertically opposite angles you can find around you. That's all for now, and we'll see you next time.
Thanks, Will. Time to watch another of our My Place stories. That's when we shine the spotlight on a student who lives somewhere in Queensland and ask them to tell us a bit about themselves and their community.
My name is McCullen. I'm from Dumajee in northwest Queensland. I'm sitting at school at the moment, and while I'm here I like doing manual arts, and when I'm in the manual arts room I'd like to make didgeridoos, clapsticks and boomerangs. So this is the catapercha tree. The sap is poison, but you can use part of it to heal your sores. We are using it at school to make some boomerangs. Here we are in the manual arts room, and here are some of the artifacts me and some of the students made. And last year we sold our products in cans to tourists from many countries.
When you think of NASA, do you think of space, astronauts, the moon, satellites and spacecraft? Did you know that this American space agency has also had a big influence on things down here on Earth? The research scientists at NASA have been helping improve household items since 1958. Today in Science, we're going to learn about some of the innovations that help make our lives easier.
It is easy to think that what happens way up there, outside the Earth's atmosphere, has nothing to do with our day-to-day lives. But did you know that there are things we use every day that exist only because of space research, exploration, and technology? That's right. Space exploration touches our lives in more ways than we might think. Today, we are going to look at a few space-inspired objects that are making life better for all of us here on Earth. Let's start by taking a look at this mobile phone. If we turn it over, we can see the camera. A NASA scientist actually developed the technology that is found in the camera of mobile phones. In fact, the idea of the digital camera was first discussed in the 1960s at the NASA Jet Propulsion Laboratory, because scientists wanted to capture images of planets, stars, and galaxies which aren't always that bright or close to Earth. So, a more powerful camera was required. This idea was then further developed almost 30 years later, in the 1990s, because scientists wanted to reduce the size of cameras on spacecraft whilst also increasing the quality of the images captured. It is this technology that we now have in our mobile phones. Tiny cameras that capture high-quality photos of important moments in our lives. Now, take a look at this device. It kind of looks like a chunky mobile phone with an antenna on top. It is actually a satellite communicator that sends and receives messages anywhere in the world using the satellites that are orbiting the Earth, like the one in this photo. If you travel to remote places in Australia where mobile phones do not work, then this device is the only way that you can communicate with family and friends. Today's versions even provide directions for us to follow as we drive from one location to another, which is much easier than using old-fashioned paper maps. Now, as you can see, I wear glasses to help see more clearly. Do you wear glasses? Maybe you have family or friends that wear glasses. Remember, space environments contain sharp dust particles that can damage astronauts' helmet visors. So NASA had to create scratch-resistant visors so the astronauts could see clearly when they were outside of the spacecraft. The optical industry, or the industry that makes glasses, have used this research to make eyeglasses 10 times more scratch-resistant than ever before. Because I wear glasses every day, I am benefiting from this technology. Now, when scientists started to investigate the temperature of stars, they realised that a regular thermometer just wasn't going to work. So NASA tried out infrared technology. Infrared light energy cannot be seen by the human eye, but by inventing a way to detect the infrared radiation released by stars, scientists could read their temperature. Take a look at this thermometer. You may even have one in your own medicine cabinet at home. It's an infrared ear thermometer and is an everyday application of the technology that NASA used to measure the temperature of the stars. Hospital versions of this type of thermometer can take your temperature in under 2 seconds. So next time you check your temperature, think about how this technology is also used to examine the stars in space. Now let's turn our attention to the garden shed. Imagine going all the way to the moon to collect samples and carry out experiments and having nowhere outside the spacecraft to plug in the power tools. Even if we did, the power cords wouldn't be long enough for us to walk any distance. Well, NASA has invented powerful motor drills with rechargeable long-life batteries. Today we benefit from this technology through the variety of cordless tools that we have around the home, like this one, which has a rechargeable battery at the bottom. It is much safer to use this cordless tool than to have electrical power cords running across the bench while we work. Now, have you had or do you currently have braces? Any of us who have ever had braces have walked around with NASA technology in our mouths. How crazy is that? We are lucky because we can now wear plastic-like braces, which are called invisible braces. Not that long ago, braces were fully metal. We get to wear invisible braces thanks to research conducted by NASA. They are made from a substance called translucent polycrystalline alumina. It was first developed to protect radar equipment, that is, equipment that is able to detect radio waves from across the universe. Wow, Can you imagine what our lives would be like without this space technology? Space technology has improved the quality of our communications, cameras, glasses, braces, tools, and medical equipment. Science and technology really is everywhere, and it has made our lives easier and healthier. I wonder what the future of space technology will hold. Okay, let's recap what we've learnt today. We now know that there are things that we use every day that exist because of space research, exploration, and technology. And these everyday items make life better and easier for us here on Earth. Now it's your turn. Today, you might like to design an improvement for an object around the home. Let your creativity run wild. How could you change the object to benefit other people, to make our lives easier and healthier? You might like to sketch and label your design in a scientific journal. Thanks for watching. See you next time.
Isn't that interesting that we all have benefited in some way from those first steps onto the moon all those years ago? Thank you so much for sharing our learning journey today. We hope that you'll be back with us again for our next lessons. Until then, stay safe and positive and make sure that you're keeping fit and putting all our health messages into practice. Bye for now.
Authorised by the Queensland Government, Brisbane.